Okay, so today we're going to talk about Pythagorean theorem and its converse. So the first thing we'll talk about is just the general Pythagorean theorem. And theorem 8.1 is the Pythagorean theorem, and it states that if triangle ABC is a right triangle, then the leg 1 squared plus leg 2 squared will equal the hypotenuse, which we know is a squared plus b squared equals c squared. So the first thing we need to make sure that we remember is that the legs are the sides that are created by this 90-degree angle, okay? And that the hypotenuse is going to be um, the side that is across from the 90-degree angle, okay? So C is going to be the hypotenuse, and A and B will be the legs creating this 90-degree angle. So when we have this situation, we can square each of the legs and add them together, and that will give us the hypotenuse squared. Um, so then we will have to find the square root to find the actual side length. There's another term that we need to talk about, and that's the Pythagorean triple. And a Pythagorean triple are three whole numbers, okay, non-zero numbers that satisfy this particular equation. Okay, and the smallest Pythagorean triplet or triple is the 3, 4, 5 triangle. And we often use that one for examples because it's the smallest value. Okay. For our first example, it says the legs of a right triangle have lengths of 10 and 24. What is the length of the hypotenuse? So we'll plug in 10 and 24 as if it are side A and B, and we'll say 10 squared plus 24 squared will equal the hypotenuse, or the unknown side, which is c squared. So we find out that 10 squared is 100, 24 squared is 576, and that's going to equal c squared. If we add those together, we get 676 equals c squared. We'll square root both sides with that, and c will equal 26. Okay. The next part of the question is, do these form a Pythagorean triple? Well, we have to ask ourselves, are they three whole non-zero numbers? Okay, and the answer, of course, is yes. And then the second one is, do they satisfy a squared plus b squared equals c squared? And the answer is yes. So therefore, yes, they are a Pythagorean triple. The next example, we're given the hypotenuse of the right triangle is 12, and the leg is 6. And we'll need to find the other leg. So we'll say that 6 squared plus, and I'm just going to say b squared, you could use any variable here for the second leg, equals 12 squared. Okay, so that means 36 plus b squared equals 144. I'm going to subtract 36 from both sides. Okay, and I get b squared equals 108. Okay, that's not going to be a perfect square, so b is going to equal the square root of 108. And I think that that may be divisible by 36. Let's see. Yes, it is. So that's going to be, factor into the square root of 36 times the square root of 3. Square root of 36 becomes 6. And then the square root of 3 cannot be simplified. So b will equal 6 times the square root of 3. And that will be my final answer in radical form. The converse, if you remember, is just the flip-flop. So if the statement is if A, then B, the converse would be if B, then A. So the converse of the Pythagorean theorem states that if A squared plus B squared equals C squared, then the triangle is the right triangle. So it's just flip. And the way we check this is we're going to take three values and see if it actually fits the Pythagorean theorem. Now the first thing we have to look at when we look at these three values is which one will be C. Because A and B are interchangeable, they're both legs, but C is not. And we remember that C is across from the 90-degree angle, and it's always the longest side. So C is always the longest side of your triangle. Okay, so this value, 50, will actually represent C in this particular case. So we'll say 16 squared plus 48 squared, and we'll put a question mark over our equals because we're not sure, and we'll say 50 squared. So I'll punch in my calculator 16 squared, and that becomes 256, okay, and then 48 squared, which is 2304. Keep my question mark because I'm still not sure, and 50 squared is 2500. If I add 256 to 2304, I actually get 2560. So that does not equal 2500. Therefore, this is not a right triangle. Now, another relationship that we haven't really explored before now is the acute and the acute and the obtuse triangle. Using the a squared plus b squared and c squared relationship, we can actually determine not only if the triangle is right, but if the triangle is obtuse or acute. If the sum of a squared plus b squared is less than c squared, meaning c is greater than a squared plus b squared, then we will have an obtuse triangle. Okay? And if the sum of a squared plus b squared is actually greater, meaning these two added together, squared and summed, are greater than c, then we will have an acute triangle. Okay? So we can use that same relationship that Pythagoras found for the right triangle to determine whether we have an acute or an obtuse triangle. Okay? And remember that obtuse triangles have an angle that's more than 90 degrees, right? And less than 180, right? And then an acute triangle has all angles are less than 90 degrees. Okay, so then we'll take that information and determine what kind of triangle we have. And this example 5, it says if the triangle has 7, 8, and 9, what is it? Well, again, C is going to be my longest side, so I'm going to say 7 squared plus 8 squared, and I'm going to put a question mark because I really don't know what the relationship is to 9 squared. So 7 squared will give me 49, 8 squared will give me 64, and I don't know how that relates to 81. So 49 plus 64 equals 113. So 113 is going to be greater than 81. So if a squared plus b squared is bigger, then what kind of triangle do we have? We will have an acute triangle because the squared sum of the sides is greater than c squared. Okay? So if you flip over here, you will find some practice problems, and this will be the homework that was assigned for 2-5, and it requires requires you to use the Pythagorean theorem and also to look at the Pythagorean triples as well as determine whether or not the triangles are acute, right, or obtuse.